Imagine waking up one morning to find out that everything you thought you knew about the world, about reality itself, was just a sliver of a much bigger picture. That's exactly the kind of revelation the universe offers us when we dive into the question, how did the universe begin? Many think it's a straightforward story, Big Bang, some stars, a few galaxies, and boom, here we are. But what if I told you the truth is far more mind-boggling? The origins of the universe are a tale filled with mysterious forces, invisible particles, and a cosmic drama that makes any blockbuster movie seem like child's play. This isn't just some academic debate for scientists in white coats. No, this question hits at the core of our very existence. If the universe had a beginning, what sparked it into being? Was it a random chance or a calculated design? And what about the laws of physics? Did they just happen to be perfectly set for life, or is there something deeper going on? These questions are more than just philosophical musings, they are keys to unlocking the secrets of existence itself. Stick around, and you'll discover insights that might just change how you see everything, literally everything. So, if you're ready to challenge what you think you know, if you're prepared to embark on a journey that stretches across time and space, buckle up. We're about to explore the origins of everything, diving deep into a narrative filled with explosive beginnings, invisible forces, and the ultimate quest to understand where we come from. This isn't just about stargazing or pondering in the quiet of the night, it's about understanding our place in the cosmos. Ready to uncover the greatest mystery of all time? Let's dive in. The universe's story starts with a bang, a big one, 13.8 billion years ago. Imagine everything you see, touch, or know packed into a tiny point, smaller than a grain of sand, yet holding the power of all existence. It's hard to fathom, right? This moment, known as the Big Bang, wasn't just an explosion but rather a rapid expansion from this singular point. It raises profound questions. What sparked this event? Why did it happen then and not earlier or later? If you're thinking about cause and effect, you're on the right track, but this event transcends our usual concepts of time and space, creating a puzzle for both scientists and philosophers. From that singularity, the universe began to stretch outwards, much like a balloon inflating. But this expansion didn't stop, it's still happening today. It makes you wonder, what existed before this event? Was there even a before? These questions push the boundaries of human understanding and challenge our perception of existence itself. You could compare it to thinking about the edge of a map. Does it just stop, or is there something beyond? Similarly, thinking about the start of the universe stretches our imagination and invites us to explore concepts beyond our everyday experience. As we ponder these mysteries, it becomes clear that the story of the universe is also a story about us. After all, everything that exists now, including every atom in your body, was born from that initial spark. It's a humbling thought, one that connects every part of our existence to a shared origin. This perspective encourages us to ask deeper questions. What role do we play in this vast, ever-expanding universe? How do our lives fit into the grand scheme of things? This curiosity drives us forward, ready to uncover the next piece of the cosmic puzzle. After the Big Bang, the universe didn't just sit still, it expanded at an extraordinary rate, a phenomenon known as cosmic inflation. Imagine blowing up a balloon, but instead of taking a few breaths, it expands faster than you can blink. This rapid expansion set the stage for everything that would follow. Scientists believe this inflation smoothed out the universe, making it the vast and seemingly uniform expanse we observe today. But here's where things get intriguing. What if the universe isn't just on a one-way trip to expansion? Enter the idea of the cyclic universe or the Big Bounce. This theory suggests that the universe could be in a constant cycle of expanding and contracting. Imagine it like a cosmic heartbeat, expanding out, then pulling back in, only to explode outwards again. It's like a movie on repeat, with each cycle potentially leading to a new version of the universe. This concept shakes up our understanding, making us think, if this has happened before, could it happen again? And if so, what does that mean for our current universe? These early cosmological theories give us different lenses to look through, each offering a unique glimpse into the nature of our universe. Are we in a one-time cosmic event, or are we just part of an infinite loop of beginnings and endings? It's like trying to decide if life is a single race or a relay, with no clear finish line in sight. The beauty of these theories is that they open up endless possibilities, each one sparking curiosity and fueling the quest for knowledge, keeping us ever eager for the next discovery. When you gaze up at the night sky, you're looking at a vast expanse that stretches beyond imagination. But here's the catch: we can only see so far. Our view of the universe is like looking through a small window. The light from distant stars and galaxies takes time to reach us. Because of the speed of light, which is incredibly fast but not instant, we only see objects as they were in the past. Think of it like receiving a postcard from a friend who's been traveling for years. The picture shows where they were, not where they are now. This limit creates a fascinating situation. The farthest we can see is called the observable universe, a bubble around us defined by the distance light has traveled since the Big Bang, around 13.8 billion years ago. Beyond this, there could be more galaxies, stars, or perhaps even other universes. But for now, they're hidden from us, like the pages of a book we haven't yet turned. It's a humbling reminder of how much more there might be, just beyond our cosmic horizon. So, what does this mean for our understanding of the universe? It's like trying to solve a puzzle with some of the pieces missing. We have to guess and infer based on what we can see, and every new discovery is like finding another piece. Yet, even with these limitations, our curiosity pushes us forward. After all, just because we can't see something now doesn't mean it isn't out there, waiting for us to uncover it. This thirst for exploration keeps us looking up at the stars, dreaming about what lies beyond our current reach. Right after the Big Bang, the universe was a chaotic swirl of energy and particles, expanding faster than you can snap your fingers. This period, known as rapid inflation, set the groundwork for everything. Picture it as a wild cosmic dance where particles began forming and interacting, governed by the universe's four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. These forces are the unseen architects, shaping the very fabric of reality and determining how everything, yes, everything, comes together and stays in motion. Gravity, for instance, isn't just what keeps your feet on the ground, it's what pulls galaxies together, allowing stars to form and solar systems to exist. Electromagnetism gives us light, heat, and everything electrical, influencing the formation of atoms and molecules that make up the stars and planets. The strong nuclear force binds protons and neutrons in the heart of atoms, while the weak nuclear force plays a crucial role in radioactive decay, helping stars shine. Think of these forces like different teams in a construction project, each one vital to building the universe as we know it. This intricate interplay of forces and particles is what allows the universe to have such a rich and varied structure. From the smallest atom to the largest galaxy, everything is a product of this delicate balance. It's a bit like cooking with just the right mix of ingredients, too much or too little of one, and you end up with something entirely different. As we look deeper into these forces, we're not just understanding the universe, we're uncovering the rules that govern all existence, providing clues that could help us unlock even more cosmic secrets. In the universe's infancy, known as the Planck era, things were downright bizarre, so strange, in fact, that our usual understanding of physics simply doesn't apply. Imagine a time when the universe was incredibly small and dense, a mere fraction of a second after the Big Bang. Here, quantum physics reigned supreme, and the forces we're familiar with, like gravity, didn't behave the way they do now. It's like trying to use a roadmap for a city that hasn't been built yet. The usual directions and rules just don't fit. During this mind-boggling phase, space and time were fluid concepts, fluctuating in ways we can hardly imagine. Think of it as a chaotic dance floor where every step changes the rules of the dance itself. In this quantum playground, particles popped in and out of existence, and the traditional boundaries between cause and effect blurred. It's a bit like watching a magic show where the tricks are so good, even the magician is surprised by the outcome. What's fascinating about the Planck era is how it sets the stage for everything that follows, yet remains a mystery we're still trying to decode. It's as if the universe kept its most profound secrets locked away in those first fleeting moments. Scientists are like detectives, piecing together clues from the early universe to understand how these quantum quirks gave rise to the orderly cosmos we see today. It's a humbling reminder of how much we have yet to learn and how the quest for knowledge often leads to more questions than answers. In the chaotic aftermath of the Big Bang, as the universe expanded and cooled, something incredible happened, the formation of the very first elements. This process, known as Big Bang nucleosynthesis, took place within the first few minutes of the universe's existence. Imagine a cosmic kitchen where temperatures are hotter than the core of any star, yet in this intense heat, the simplest elements, hydrogen, helium, and a sprinkle of lithium, begin to form. These were the building blocks for everything that would come after, the seeds of all matter in the universe. Hydrogen, the lightest and most abundant element, was the first to emerge, followed by helium, which is slightly heavier, and trace amounts of lithium. Think of these elements as the primary colors in a painter's palette. With just these three, a whole universe of complexity eventually unfolded. From these humble beginnings, all the heavier elements, like carbon, oxygen, and iron, would later be forged in the fiery hearts of stars. But it all started with this simple trio, created in the extreme conditions just moments after the Big Bang. Understanding Big Bang nucleosynthesis helps us trace the universe's story back to its earliest chapters, showing how even the simplest ingredients can lead to something incredibly complex. It's like baking a cake with just a few basic ingredients, but ending up with a multi-layered masterpiece. By studying these elements, scientists gain insights into the conditions of the early universe, giving us clues about how everything, from galaxies to life itself, came into existence. And it's this curiosity that keeps us looking deeper, eager to understand more about the cosmic recipe that made us all. As the universe expanded and cooled after the Big Bang, a remarkable transition took place. The intense heat that initially prevented atoms from forming began to wane, allowing protons and electrons to come together to form the first atoms, primarily hydrogen and helium. This process, known as recombination, was like a cosmic coming-together party. With atoms now stable, the universe transformed from a seething, opaque plasma to a transparent space, enabling light to travel freely for the first time. Imagine the lights turning on in a room that had been dark for ages. This light is what we now detect as the cosmic microwave background, CMB, radiation. The CMB is like a snapshot of the infant universe, a cosmic baby picture that scientists can study to understand the conditions just 380,000 years after the Big Bang. This faint glow, detectable in every direction of the sky, provides an imprint of the universe at that early stage, preserving a record of its temperature, density, and movement. Think of it as a fingerprint left behind by the Big Bang, a clue that has helped us piece together the story of how the cosmos unfolded. It's incredible to think that with today's technology, we're able to glimpse this ancient light and decode its secrets. What makes the CMB so fascinating is that it's not just a relic, it's a map. It shows us tiny fluctuations that eventually led to the formation of galaxies and clusters, the very structure of the universe as we know it. By studying these patterns, scientists have been able to uncover details about the universe's composition, age, and even its ultimate fate. It's like finding an old treasure map that doesn't just show you where the treasure is buried, but also tells you how the land was formed in the first place. And as we continue to explore this map, we unlock more secrets about our cosmic origins. The discovery of the cosmic microwave background, CMB, is a classic example of scientific serendipity. In 1965, two radio astronomers, Arno Penzias and Robert Wilson, were conducting experiments with a large antenna in New Jersey, trying to detect faint radio signals from the Milky Way. Instead, they stumbled upon a persistent background noise that seemed to come from every direction. No matter what they did, cleaning pigeon droppings from the antenna or checking their equipment, they couldn't get rid of this noise. What they had actually found was the CMB, the afterglow of the Big Bang, providing a snapshot of the early universe. This accidental discovery was a turning point in cosmology, providing substantial evidence that the universe began with a hot, dense state, the Big Bang. Before this, the Big Bang theory was just one of several competing ideas about the universe's origins. The CMB was like finding a missing puzzle piece that suddenly makes the whole picture clearer. It confirmed predictions made years earlier by physicists and solidified the Big Bang as the leading explanation for the universe's beginning. Imagine working on a theory for years and then, quite by accident, having your hunch confirmed by a completely unexpected finding. That's the beauty of science, it's full of surprises. The CMB isn't just a static relic, it's a dynamic tool that continues to provide insights. By studying its subtle variations, scientists can learn about the early universe's conditions, from its temperature to its density fluctuations. These fluctuations eventually led to the formation of galaxies and the large-scale structure of the universe. In many ways, the CMB acts like a time machine, allowing us to peer back billions of years to understand how everything came to be. It's a reminder that sometimes, the answers to the biggest questions in life can be found in the most unexpected places, encouraging us to keep exploring and questioning the world around us. Once the universe began to cool, the next chapter in its grand story involved the formation of stars and galaxies. Picture this: over millions of years, tiny clumps of matter slowly began to gather, drawn together by gravity's invisible hand. These clumps grew denser and hotter, eventually igniting into the first stars. These stars were more than just celestial ornaments, they were cosmic forges, where the first heavy elements were born. Through a process called nuclear fusion, hydrogen atoms fused to create helium, and over time, these stellar factories produced heavier elements like carbon, oxygen, and iron, building blocks essential for planets and, eventually, life. As stars lived and died, they scattered these elements into the cosmos, enriching the universe's primordial soup. Supernovae, the explosive deaths of massive stars, played a crucial role here. When a star explodes in a supernova, it creates a spectacular light show and a powerful shockwave that blasts newly formed elements into space. Think of these explosions as cosmic recycling events, seeding the universe with the ingredients needed to form new stars, planets, and even you and me. It's like a giant cosmic cooking class, where each generation of stars passes down a richer recipe book of elements to the next. This continuous cycle of star birth and death has shaped the universe as we know it. Over billions of years, galaxies formed and evolved, creating intricate structures across the cosmos. Every atom in your body, from the calcium in your bones to the iron in your blood, was forged in the heart of a star. It's a humbling thought that we are all made of stardust. It connects us to the universe in a profound way, reminding us that the cosmos isn't just out there, it's within us, too. And as stars continue to form and die, the universe's story of creation is far from over. Today, our understanding of the universe paints a picture that's both awe-inspiring and mysterious. The cosmos is not just made up of the stars, planets, and galaxies that we can see. In fact, all the normal matter, everything from the tiniest dust particles to the largest galaxies, only makes up about 5% of the universe. The rest is something far stranger: dark matter and dark energy. Dark matter, which makes up about 27% of the universe, is like an invisible scaffold, providing the gravitational glue that holds galaxies together. Yet, despite its significant role, we can't see it directly. It doesn't emit, absorb, or reflect light. It's there because we can observe its effects, but beyond that, it's a riddle wrapped in an enigma. Then there's dark energy, which is even more perplexing. Making up about 68% of the universe, dark energy is believed to be responsible for the accelerated expansion of the cosmos. Imagine blowing up a balloon, and as you do, not only does it get bigger, but it starts to stretch faster and faster on its own. That's dark energy in action. It's a force that seems to work against gravity, pushing galaxies apart at ever-increasing speeds. The concept of dark energy challenges our understanding of physics and the fundamental forces that govern the universe. It's as if we're trying to read a book with most of the pages missing, and the plot keeps changing with every new discovery. Understanding dark matter and dark energy is one of the greatest quests in modern science. It's like knowing there's an entire hidden section of the universe waiting to be discovered. Just think about it. We've mapped out the stars, walked on the moon, and even sent probes to the edge of our solar system, but when it comes to these mysterious components, we're still very much in the dark, pun intended. As scientists continue to study these cosmic mysteries, we're left with more questions than answers, reminding us that the universe still holds many secrets yet to be uncovered. So, here we are, standing at the edge of understanding, peering into the vastness of the universe with new eyes. We've journeyed from the explosive birth of the cosmos to the mysterious forces that continue to shape it today. But the real question is, what will you do with this knowledge? Will you let it stir your curiosity, pushing you to explore more about where we come from and where we're headed? Or will you take comfort in the fact that, despite all our advancements, the universe still holds countless secrets waiting to be uncovered? Remember, understanding the universe is not just about gazing up at the stars, it's about looking within and realizing the incredible journey of existence that brought us here. Each of us is a piece of this cosmic puzzle, and by learning more, we get closer to understanding our place in it. So, what's your next move? Will you dive deeper into these mysteries? Perhaps start by exploring the latest discoveries in cosmology or even engage in a simple stargazing session, letting the night sky inspire your next big question. And hey, if you found this journey enlightening, why not stick around? Subscribe to the channel, turn on those notifications, and let's continue exploring these incredible topics together. There's so much more to discover, and I'm excited to have you along for the ride. After all, in a universe this vast, there's always something new to learn, something that can change the way we see the world and ourselves. Are you ready to keep exploring?